Hi everyone, what's going on? This is George from Data Academy. Welcome to today's tutorial on stacking and voting. Let's get started by importing all the libraries, reading the data, and then splitting the data into training and test sets as always. So first, we're going to do a quick round of spot checking of different algorithms. What is spot checking, you might be asking? Well, the idea is without doing experiments in machine learning, it would be almost impossible for us to tell which algorithm is going to work better for the specific data we have on hand. So the idea of spot checking is literally to try some common algorithms and to see which one might give us a better result for the data set we have. So that's what I'm doing here. I'm going to try different common algorithms, including some linear algorithms, some nonlinear algorithms, and then some ensemble algorithms. I really would like to see which one might give me a better result. So next, I'm putting all the different algorithms, including their names and the actual instantiated algorithm or the model, into a Python dictionary. This way, I'm able to loop through each and every one of them and test them out. So for every algorithm, I'm going to train them on the training set and test them on the test set. And then I'll print out the result. So now looking at the result here, it seems like in general, the linear algorithms, they perform a little worse. And then the nonlinear algorithms, they seem to be somewhat better, but not too much. But really the winner here is the ensemble algorithms. So that being said, we are going to use maybe more of these ensemble learning algorithms to do our stacking and voting below. So first of all, what is stacking? Let us look at this example here. So the idea behind stacking is that now we are going to build a new higher level model on top of the individual models we might have. So this higher level model, let's call it the meta model. So this meta model, it is going to use the individual predictions from each of these lower level models as the features now. And it is going to use the original labels as the labels. So now essentially we have a new data set, and this meta model is going to be trained on this new data set. So in this case here, for the first instance or the first row of data, classifier A predicted this is class A, and then classifier 2 says this is class B, and so on and so forth. And then we're going to use all these predicted labels now as the features, and then the original labels as the labels. So now we have this new data set, and we're going to build this model. So that is basically the idea behind stacking. So in this case here, we're going to use these algorithms as we discovered above to use them as all the different estimators that we're going to stack together. So then we're going to use this stacking classifier and then supply all the estimators like this, and we're going to specify the final estimator, which is the meta model I just talked about. And here I'm going to use the logistic regression model or algorithm as the final estimator. And if we do it this way, we essentially have a new meta model, and we can also cross-validate this meta model like this. So this is the result. Not too bad. And now let's look at voting. So the idea behind voting is literally we are going to choose or make the prediction based on majority voting. So now look at this row here. We have the majority, which is a class B, right? So now I'm going to predict this is going to be class B instead of class A. So this is just based on the majority voting here. So that's the idea behind voting, the voting classifier, and we can use it similarly by providing the estimators, and then we can also cross-validate. If we do that, we can see the accuracy is actually better in that not only it is higher, but also the standard deviation is lower, which is definitely a good thing, which means we have a more stable model. So that is everything for today regarding stacking and voting. Thank you so much for watching, and I'll see you next time.